This is Himabindu from the Department of CSMT. So today in this video I would like to explain about the problems on conversion from NFA, Epsilon NFA to DFA. So previously we discussed about the conversion between the NFA to DFA, and now we have the epsilon moves in the NFA. So non-deterministic finite automata which is having the epsilon moves. So that how to convert this epsilon moves NFA to deterministic finite automata we will see. So here epsilon NFA is nothing but it is one of the finite automata. So we have the types of finite automata with the output and without output. The finite automata with output, without output. So here we are discussing about the finite automata without output. So we already discussed about the NFA, DFA. So deterministic finite automata and non-deterministic finite automata. And now epsilon NFA. So epsilon moves in the NFA. So non-deterministic finite automata which is having the epsilon moves. So here we can convert from one form to another form. So here we can convert it to epsilon NFA to, so epsilon NFA to NFA and NFA to DFA. So NFA to DFA. We can convert this into another form. So this is about the equivalence between these two things. So here epsilon NFA, while we are having the input as an epsilon NFA, first we need to convert it to a normal non-deterministic finite automata, and then we have to convert the non-deterministic finite automata to a deterministic finite automata. So and with output we have two types of machines. One is Murray machine and Millet machine. So we can also convert this Murray to Millet, Millet to Murray. These are also two equivalent to each other. So when we can convert from one machine to another machine. So this is about the epsilon NFA, where we discussed this finite automata, and two types of finite automata we have. One is with output and without output. And here, what is the need of this epsilon NFA? So what is the need of this epsilon NFA? So an epsilon NFA is formed by a regular expressions for a language. So if you observe the types, we have four types of grammar. So in that one, the first one is about the type 3 grammar. So type 3 is about the regular expressions or regular grammar. So regular grammar. So with this regular grammar, we can construct regular expressions. Regular expressions, and also we can form a regular languages. So this is about all the type 3. So with these three things we can design or model the finite automata. So what we require for the finite construction of finite automata, these are the things we need to require for the construction of finite automata. And what is a need of this epsilon NFA? So an epsilon NFA is often converted to a simple NFA. First step, we can easily convert it to a normal NFA. We have to remove the epsilon moves from the non-deterministic finite automata, and we can convert it to a normal non-deterministic finite automata. And the obtained NFA is then used for making. So after removing all the epsilon moves from the non-deterministic finite automata, we can also convert it to a deterministic finite automata, that is nothing but DFA. We can convert it to a DFA, deterministic finite automata. And epsilon NFA has null or epsilon moves. Epsilon moves transitions from one state to another state. So as we discussed, so epsilon NFA is nothing but we have the epsilon moves or null moves in the non-deterministic finite automata. And next, coming to the definition of epsilon NFA. So same as the NFA is having the phi tuple notation. So this epsilon NFA is also having the same 5 tuple notation. So let me explain this every tuple. So Q is nothing but it is a finite set of state. It is a finite set of states. So to construct a finite automata, how many states are required? Either it is an initial state or final state. Those are all comes under the capital Q. That is nothing but a finite set of states. And sigma is nothing but it is the input values or alpha bits what we are going to form the language. So we can form the strings in that language. So what are the input values what we are taken for the construction of finite automata? Those are represented as a sigma. And next this D or delta, that is nothing but it is a transition. So transition, how many states we have to perform the transitions for every state to the every input. So that is represented as a Q cross sigma. So Q cross sigma along with the union of epsilon moves. So in the states we have epsilon moves, so we have to include that epsilon moves with the delta transition. So what is the value of this delta is nothing but 2 power q. So how many states are there? We need to write all the states. That is nothing but 2 power q is the transition function. So Q on seeing the empty symbol move to another state. So here while seeing the Q which is having the epsilon symbol, it is moving to the INA. It is move to the any state that represents the Q power 2 power Q. So it is a power set of Q. And Q naught which is a initial state which is belongs to the capital Q. As we said, the Q naught and final state both are the subset of both are the states we have taken from the capital Q. And F is the subset of Q, so is the subset of accepting states. So here F we are not taking a single state. So based on the transitions, based on the language, we have multiple final states. So those are all comes under the capital Q. So it is taken from the capital Q, finite set of states. So this is about the definition of Epsilon NFA. So Epsilon NFA. So here only the difference between NFA and Epsilon NFA is here the transition, the delta, which is also including the epsilon moves. So how to remove this epsilon moves from the Epsilon NFA, we will see. So every note here we have one more important point. Every state on epsilon goes to itself. So suppose here it is one initial state is there. So it is leading to the one taking one as an input and it is having the Q2. So here every state. So here there is no epsilon move, but here every state itself it is having the epsilon transition. So that is what we are explaining here. So in case of transactions, which in case of NFA, we don't have any epsilon. So only epsilon for every state. So we need to consider for every state itself it is having the epsilon symbol. And here are the steps to remove the epsilon symbol, and we can convert the given epsilon NFA to normal NFA. So here the first step is to find out all the epsilon transitions from each state from Q. So here suppose we have the Q naught and a Q naught, it is epsilon symbol and it is reaching the state Q2, and this is 1, it is reaching 1. So here one put. So here epsilon transition. So here we have a 3 states. So here for 3 states we need to find out the epsilon closure. So epsilon closure for every state. So epsilon closure for every state. So here we have a 3 states. So here I am writing for every state we need to find out the epsilon closure. So here how many states are there? Here 3 states are there. So for every state we are writing the epsilon closure. So how to write this epsilon closure? So here epsilon closure of Q naught. So Q naught here, according to this diagram, transition diagram, we have some Q naught, we have epsilon transition is for Q2, and also self state it is having the epsilon symbol. So that the states are Q naught, comma Q2. So these two are having the epsilon moves. And next epsilon closure of Q1. So Q1 it is not having the any epsilon moves, so that one point, important point, every state itself it is having the epsilon symbol. So what is the epsilon closure of Q1? Q1 only. And epsilon closure of Q2, it is not having any epsilon moves, and it is not leading with the epsilon move, so that itself it is having. So what is the value? Q2. So like this, we need to find all the epsilon transitions. So epsilon closure for every states for the given epsilon NFA. So first step, what we have to do, we have to find all the epsilon transitions or epsilon closure for every states. And second step, then a transition of can be obtained. So transition 1. So we are differentiating further. Epsilon NFA is having one transition. So that is named as delta, and we are converting that to a normal NFA, so that name transition is named as delta 1. So here delta 1 transition can be obtained. To define this delta 1 transitions, we have the delta 1 transitions means epsilon closure on delta moves. So here what we have the result. So for every result we need to find the input values and where it is input values of transition. So here Q naught Q2 is there. Individually we need to find Q naught transition of Q naught, comma, what are the inputs here? We are taking 0, 1. We will take 0 and 1. So here we have 0 is there. So how many inputs are there? For every input we need to find the transitions. So here Q naught, comma Q2. So 0 input. So 0 input which is leading to Q naught 0. So Q naught 0 is nothing. So pi, and Q2 0, it is having Q2. So the result is Q2 only. So like this we need to find the transition 1 for the given epsilon closure values. So here the epsilon closure what we got from the step 1, we need to find all the transitions for results. What we got the results for every input we need to find the transitions. And next third step, so step 2 repeated for each input symbol and for each state of a given NFA. So how many states are there? We need to find all the transitions for epsilon closure states. And this 3 is repeated. This step 2 is repeated until we need to finish all the states. And then last step is by using the resultant status, the transition table. So later we can construct a table, and then we can convert the transition table to a transition diagram. So this is how we are going to convert the epsilon NFA to NFA. So we can clearly explain with these examples. So here is the one example what we have taken. So here let me write the definition of this transition diagram. So coming to the definition, so here one epsilon transition, so NFA, which is having the value. So Q, here Q, capital Q is nothing but we have the 3 states 1, 2, 3. So here what are the 3 states? Q naught, Q1 and Q2. And sigma, so this is about the capital Q, and the sigma which is equal to input values. So here how many? 0, 1, 2. 0, 1, 2. And next epsilon is there. and sigma is there, and next q naught is the initial state and final state is q2, and delta we need to write. So by seeing this one, we can write the transition table also. So now we require the, so delta is there and we need to find the delta 1. So first step is what we have to do. We need to find the epsilon closure. So epsilon closure we need to find. Epsilon closure for every state. Every state. So here what are the states we have? So we have a 3 states. So let me write for Q naught, and this, and we have, so Q naught we have a 3 values, so that let me write epsilon closure. We need to first find out epsilon closure, and we need to take the input values like 0 is there, and epsilon closure we need to find epsilon closure. So for Q naught, epsilon moves, so itself it is having the epsilon symbol, and Q1 is also having, and Q2 is also having the epsilon symbol. So that for Q naught we have 3 values. One is Q naught, Q1 and Q2. So finding the epsilon closure of Q naught, we got the 3 values, and we need to find the transitions, that is nothing but transition of Q naught comma 0 and transition of Q1 comma 0 and transition of Q2 comma 0. And what is the result? So that the transition of 0 we have Q naught, and transition of Q1 with the 0 input pi, nothing is there, and transition of Q2 comma 2 0, there is nothing. So and again we need to find the epsilon closure. So epsilon closure of Q naught, what we got the result, this is the epsilon closure Q naught. So that, and next we need to find the epsilon closure Q naught of, we find the 0 input and 1 input we need to find, and epsilon closure of, so Q naught, Q1 and Q2. So epsilon closure for input 1 we have to find. So epsilon closure, so transition of Q naught comma 1. So for one input we need to find the epsilon transition. So Q naught comma 1, what is the value? Q naught comma 1, there is nothing, no more value. And transition of, we got here, I can write this one so that it is very clear. So Q naught, so epsilon closure, and here transition of Q1 comma 1. So what is the Q1 comma 1 result? It is a Q1 state, and next transition of Q2 comma 1. So transition of Q2 comma 1. So what is the result? Q2 comma 1, this is pi. And we have only one value, that is Q1. So Q1 transition, so epsilon transition of Q1. So epsilon transition of Q1, that is nothing but we have to find the epsilon closure for Q1. So Q1 closure, we have the two values. One is Q1. So Q1, why? Because the Q1 itself it is having the state epsilon, and next Q2. So these are the two values, so that we have the result like this. And we find till now we find the epsilon closure for 1, 0 and 1 input. And now we will find the epsilon closure for Q naught only. Q naught with the epsilon closure. So with the 2 input. So epsilon closure. So what is the epsilon closure of Q naught? Q1, Q1 and Q2. And what is the result for transition of Q naught with the input 2? So what is the result? Q naught 2, there is nothing. And transition of Q naught Q1 to, so Q1 to is also nothing, and transition of Q2 2 is there. So what is the value of Q2 only? And what is the epsilon closure of Q2 is equal to this Q2 is equal to Q2 only. Itself it is having the epsilon symbol. And this is about the three input values what we have taken, and we just find the values for only Q0, and we have the two more states, one is the Q1 and Q2. We need to find the same process for two more states also. So and find the Q1 state, it is having the epsilon closure. So, and we have the three input values. So, we need to find the same thing as we discussed about the Q naught, like that we need to find for the Q1 also. Epsilon closure. So, epsilon closure of Q1, what we have, Q1 and Q2 is there. And for a 0 input, transition of Q1 comma 0 and transition of Q2 comma 0. And for these two inputs, Q1 0 is nothing, and Q2 0 is nothing. So that epsilon nothing, so there is a no more value for this epsilon closure. And one more Q1, so epsilon closure, we need to find, if now we need to find the another input value. So one is a Q1 and Q2, and what is the result of Q1 with the input symbol 1. So Q1 with the 1, we have the value Q1, and Q1 epsilon closure, we will find Q1 and Q2. And transition of Q2 comma 1. So there is nothing, pi, so no need to write pi. So and here one more, we need to find the second input symbol, that is 2 input symbol. So 0 is there, 1 is there, and 2 is there. And we need to find the epsilon closure for Q1 and Q1 comma Q2. So for transition of Q1 comma 2 input, pi value, and transition of Q2 comma 2, we have the value Q2 only, and Q2 epsilon closure Q2 only. So, and here we just finished the two states. One is Q0 and Q1. And now we will finish the Q2 state. So, Q2 which is having the epsilon closure and with the 0 input and epsilon closure. So, for the Q2 it is having the only one state and transition of Q2 comma 0. So, Q2 comma 0 is nothing, pi and pi closure. And for Q2 state, we need to find for one input and epsilon closure. So Q2 comma Q2, transition of Q2 comma 1 input. So there is no 1, 0, and what is the result? Q2 comma 1, there is nothing. So pi value. So epsilon closure also pi value. And next for Q2, so epsilon closure, so and Q2 come Q2 only. So transition of Q2 comma 2 value. Now we'll take the 2 value. So we finished 0, 0, 1, and now we will finish the 2 value. So for 2, transition of Q2 comma 2, it is the value only Q2 only. So and Q2 epsilon transition, epsilon closure, what we get? 2 only. And this is about, we finished just now, we finished all the states. So epsilon transition moves for every state. Now we will write this result. So here just now discussed about the transition. So epsilon closure we find, and now we will write the transition table. So what is the transition table we have? We need to write all the values here. So here how many states are there? We have transition. So delta transition NFA. This is the NFA what we converted. Just after by resulting status we need to find the states. So what are the input values? We have 0, 1 and 2 values. And how many states are there? Q0, Q1 and Q2. So for Q0, 0 as an input, what is the result what we got? We need to write all in the symbol. And next, for 0 input symbol, 1 input symbol, we got the value Q1, Q2. So, and for 1 input symbol, we have, so 2 input symbol, we have only Q2. And for Q1 state, pi, 0 input symbol, it is having the pi. And this 1 input symbol, it is Q1, Q2. And 2 input symbol, it is Q2 only. And for Q2, so what is the result? So for 0 input, pi, and 1 input, it is pi, and 2 input, it is Q2. And now we will same this convert into a transition. So we will convert this into a transition diagram. So transition diagram, so here the starting state is the Q0, and Q1 we have, and Q2 we have. Q2 is the final state. And for Q0, if you give 0 as an input symbol, so it is self state, it is having 0. And for Q1 is also having 0. And also Q2 it is having the 0 input. And for 1 input from Q1, so it is having the 1 input symbol for Q1 and also for the 2 input symbol. And for 2 input symbol, we have Q2 to Q. So 2. And we will write the same thing for Q1 state. So Q1 0, nothing. So Q1 1. So it is self loop, it is having the 1 input symbol. And Q1 2. So now we will write the 2 symbol from Q1 to Q2. And for Q2, Q1 to Q2, also it is having the 2 input symbol. And for Q2, it is having the Q2, 2 input symbol self. So this is how we just, if you observe, we have the epsilon moves here, 2 moves here. We are just converted without, by removing the epsilon symbol, we just converted to a normal NFA, that is epsilon without epsilon NFA. So this is how we are converting the given epsilon moves transitions NFA to normal NFA. And this is the first example. And second example we will discuss. This is this diagram. By seeing this diagram, we can also say that it is a epsilon NFA. So we just want to remove the epsilon transitions from the given NFA. So now what is the first step we need to find? And first step we need to find the state. So Q is equal to, so Q is equal to, we have the 3 states. So Q0, Q1 and Q2. And next input values are A is there and B is there. So sigma values are A comma B. And next, and initial state is Q0 and final state is Q2. And transitions, by seeing this one, we can say that many transitions are there. And now we need to find the transition of the transition. So delta dash or delta 1 we have to convert. Now, so what is the first step we need to find? We need to find all the states for every state epsilon transition. So epsilon closure we need to find for the every state. We have 3 states here. One is a Q0, Q1, Q2. So here first one is the first step what we have to do. We need to find for the Q0 epsilon closure. So epsilon closure. And how many inputs are there? We have 2 inputs. So that I will write the 2 inputs, so for same state, so Q0 epsilon closure for every input I am writing. So now we'll take B epsilon closure. So transition of Q0 with the epsilon move, so itself it is having the epsilon symbol, no other transition. So Q naught and transition of Q naught comma A. So what is the result Q naught comma A? That is a value Q1. So epsilon closure of Q1. So epsilon closure of Q1, it is having the values 2 things. That is Q1 and 2. Why? Because epsilon move is there and that is leading to the Q2 state, and itself the state, every state itself, it is having the epsilon symbol. And like that for B input also we will write. So epsilon closure of Q naught, it is a Q naught only. And transition of Q naught comma B, which is B input, it is Q naught comma B, there is nothing. So pi. So pi of closure, pi only. And we will take one more state, that is a Q1 state. So epsilon closure of Q1. So epsilon closure of Q1 is nothing but it is having the two states, one is Q1 and Q2. So transition of, we will take A input and epsilon closure. So transition of Q1 comma A input. So Q1 comma A, there is nothing is there. So pi value, pi of enclosure, pi only. And transition of Q2 comma A. So Q2 is nothing with the A input. So pi only. And same thing for the B input for the same one more state, Q1, and we need to find the epsilon closure for the input B also. And transition of Q1 comma. So transition of Q1 value, it is having the two epsilon closure, we have the two values. So transition of Q1 comma B. So Q1 comma B, there is nothing. And transition of Q2 comma B. So Q2 comma B, it is having the value Q2, and Q2 transition, it is having the only Q2 value. And one more. So state we need to take, and epsilon closure with the A input, epsilon closure. And here transition of Q2. So epsilon closure of Q2, what is the result? Only there is no other epsilon move, so that only itself it is having the epsilon symbol. So transition of Q2 comma A input. So Q2 comma A, pi value pi, and a pi of epsilon closure also pi. And for Q2 state, we need to find for the B input also. B epsilon closure. So Q2, the epsilon closure of Q2, we have only value Q2 only. Q2 comma B input. So Q2 comma B, we have the value 1 Q2, and Q2 of 2, Q2 of epsilon closure, what we got, the result is Q2 only. So we just finished all the states epsilon closure. So by seeing the results, we need to find the transition table. So transition table, so what is the values we have? So 0 A comma B values, input values, and transition 1. And how many states are there? Q0, Q1 and Q2. So for Q1 state, or these are the results, we need to write these results in this transition table. So Q1, for Q0, what is the result here? Q1, Q2 for the A input, and B input we have the pi. And for the same thing, Q1 also, Q1 it is having the pi, and B input it is having the Q2. And for Q2 also, it is A input is pi and B input is Q2. So the same transition table we need to convert it to a transition diagram. And Q0 is the initial state and Q2 is the final state, in between Q1 is there. And by seeing this transition table, we can say that we can construct the transition diagram. So Q naught while giving A as an input, it is going to Q1 and A, and also it is going to B also, Q2 also. So B value nothing is there for Q naught and Q1. So Q1 it is having the A is nothing there, and Q. So B input symbol. So B input symbol it is reaching to the Q2 state, and for Q2, so itself it is having the B input symbol. There is no transition. So this is how by seeing this diagram, there is no epsilon moves. So that we just converted this epsilon move NFA to normal NFA. So this is how we are going to convert the given epsilon NFA to normal NFA, non-deterministic finite automata. And we just discussed about the epsilon NFA2, NFA. And now where the question comes like epsilon given input is epsilon NFA, and we need to convert it to a DFA, deterministic finite automata. So how to convert this NFA, epsilon NFA to deterministic finite automata, we will see. So here were the steps we need to discuss, so that so by considering these steps, we can construct the now epsilon NFA to deterministic finite automata. So here consider the input is about epsilon NFA. So what we just now discussed, the definition of epsilon NFA. So here the definition of epsilon NFA, we need to include the every transition output with the epsilon moves. We have to convert this NFA with epsilon without epsilon NFA, so that then we can convert it to a normal DFA. And here DFA, which is we are having the two values. One is epsilon NFA. This is epsilon NFA definition, and now we will convert it to a DFA. So DFA definition. So then obtain. So here we are just now discussed about the epsilon closure of every state. So here the same process. The epsilon NFA is the input here. So we need to find all the epsilon closures for every state, so that the result what we are writing, those are all the states results. We need to write all in the same there, and then we will find obtain the transition. So whatever the results we got, so general conversion. So NFA to DFA conversion. So generally we will find the transitions for every state, so that we got the new state. So after getting the result, by seeing the result, if you see the result of the state or is a new state, so for every new state we need to find transition for new state also. So new state. So this same process here, after getting the results of epsilon closure, we got some results. So in that one, any new state is there, we need to find all the transitions. So same step we need to follow for. So while converting NFA to DFA, we have one procedure. So transition of every state, if we get the new state, we will find the transition for new state also. The same step we need to follow here after epsilon closure. So epsilon closure, we will get one result. For every result, we need to find the transition value and epsilon closure of every state. So here we need to combine all, and we will write the transition table, and then we will write the transition diagram. And the states obtained, which belongs to the Q. So whatever the states we find lastly, so new states, what are those? Those are all the new states are named as a Q naught. Q naught is the a DFA Q. So the finite set of states, and the states containing final states Pi is the final state in DFA. So whatever the result there with the final state, so those are all the states with the final states. So here this is about the epsilon NFA to DFA. We will discuss it with the example. And here epsilon NFA is the input, and we need to convert, we need to find the epsilon closure for every state. So here how many states are there? We have Q0, Q1 and Q2 is there. So we have a 3 states. So that first step what we have to do, we need to find all the epsilon closure for every state. So I will write the epsilon closure. And one more, sigma is equal to, what are the values here? A comma B is there. This is a sigma. And Q0 is the initial state and Q2 is the final state. And transitions we are doing. And A input, and we need to find for the 2 input values. So that it's epsilon closure for B input, epsilon closure. So first state is Q0. So Q0 which is having the input values, so that itself it is having, and it is leading to the Q1, and it is also having the input symbol Q2. So these are the 2 things. And transitions we need to find. Transition of Q0 comma A. So Q0 comma A there is nothing, and transition of Q0 comma B. So B it is having the Q0. So and transition of Q0 comma Q0 comma A, Q1 comma A. So Q1 comma A it is having Q0. Q1 comma A, Q1. Q2 comma A. So Q2 comma A it is also having Q1. So epsilon closure of Q1. So epsilon closure of Q1, it is the Q1 and Q2. And here also Q1 comma Q2. So getting together we result as a Q1 comma Q2. The same number, same states are repeated, so that I am writing only one time. And the same thing we need to repeat for the B input. So Q0 it is having the values, epsilon closure of Q0, we got the 3 values. And transition of Q0 with the B input. So Q0 with the B input only Q0, and transition of Q0 Q1 comma B input. So there is nothing. And transition of Q2 comma B. So there is nothing. And for Q0 epsilon closure we have the values Q0, Q1 and Q2. So result is Q0, Q1 and Q2. So here we got the values, 2 things. So one is these 3 things we need to find. So Q1, Q2 is there, and Q0, Q1, Q2 is there. So these are the 2 new states. So and we need to find for the Q2 also. Q1, Q2. So epsilon closure of Q1, Q2. And whatever the new states are there, we need to find all the new states. So, and now we will discuss about, and also we will write the Q1 state. So Q1 is result which is having the Q1 epsilon closure and Q2 also, and transition of Q1 comma. So Q1 comma A input, it is having the result Q1 comma A. So Q1 comma A, it is Q0 only, Q1 only, and Q1 it is having the Q1 and Q2 epsilon closure. And for Q2 epsilon transition, delta of Q2 comma A input, Q2 comma A, it is having the Q1 value, and it is again Q1 Q2. And next step, and we need to find for the same thing for Q0, Q1 and Q2 for the result. Q1 transition of, the transition of Q1 comma A, B input we are taking. So Q1 comma B is pi, and transition of Q2 comma B is pi, and the result is also pi. And now we will also take the two values. One is Q2 value. So Q2 we need to find the transition. So epsilon closure and A input value epsilon closure. And for here also Q2, so Q2 is only having the epsilon transition, and A input transition of Q2 comma A. So Q2 comma A is Q1, so result is Q1 Q2. And for B input epsilon closure, so B input epsilon closure, so Q2 Q transition of Q2 comma B, and result Q2 comma B is pi, so the result is also pi. So we have the values here, and now we will construct the transition table. So what is the transition table we need to find? And whatever the result we have, we need to find all the states. So here Q1 and Q2 is there. And so first transition delta, and what is the value? A comma B. And for Q0, if you observe, Q0 is the initial state, and this is the one result. If you observe, this is we need to name this thing. So let me write the naming conversion. We will write the A is equal to Q0, Q2, Q1 and Q2, and B is equal to, so here is the one more B, Q1 comma Q2, and we need to write the two states, so that, so A is the new state and B, so here A, it is having self state, it is having the result 0A as an input symbol, it is reaching the B. So A as an input symbol, it is reaching the B, and B as an input symbol, it is in the self state. And now we have the two values, that is Q1 Q2. So Q1 Q2, so result A itself, it is having the input symbol, and B is nothing but, so for the B input we don't have any, so pi only, so B there is nothing. So and B with Q2, which is having the final state, so that, so whatever there in the final state Q2, so two states are the final states. So this is how we are going to convert the NFA. So epsilon NFA to DFA. We need to take the new state names, and we need to draw the transition diagram. So this is about the conversion of epsilon NFA to DFA. And one more example. So here there are 5 states are there, so that we will find the transitions. So we will find the transitions, and we will remove the epsilon modes first, and then we will convert it to a DFA. So fine, let me write the M. So definition. So how many states are there? Q0, Q1, Q2, Q3 and Q4. 4 states are there here, and 0, 1. So 0, 1. And initial state is Q0 and final state is Q4, and transitions we are ready. And first step is, for every state, So we need to find the states. So whatever their new states are repeating, we are finding. So every state, for every state we need to find the transition. So here Q naught I am initializing with the Q naught, epsilon closure we need to write, and 0 input epsilon closure. So Q naught of epsilon closure, we have the two values. One is Q1, Q2, and we will write down. So Q naught, Q2. So Q1, Q2. So transition of Q1 comma 0 and transition of Q2 comma 0. So what is the result here? Q1 comma 0, it is having Q3, and Q2 comma 0, nothing. So Q3 epsilon closure, it is having the Q3 value only. And now we will write for the same one input. So epsilon closure, and for one input epsilon closure. So for the same state we have the values Q1, Q2, and transition of Q1 comma 1 and transition of Q2 comma 1. And here Q1 comma 1 is pi and Q2 comma 2 is Q3 only, and also we'll get the result Q3. And what is the result here? Q3. We need to find for transitions epsilon moves for the this new state, and Q3 is having the value. So epsilon closure and 1 in 0 input epsilon closure. So 0 input it is having the Q2, Q3 only. Q3 epsilon closure is Q3, and transition of Q3 comma 0 is equal to Q3 comma 0, there is nothing, so pi value only. The same thing for the B 1 input. So Q3, the result is Q3, and transition of Q3 comma 1 input symbol, so it is having for Q4 1 input and epsilon closure. So Q4, so epsilon transition of Q4, it is a Q4 only. So again what we got, the state Q4 is the new state, we need to write. So Q4, so Q4 is equal Q4 epsilon closure and 0 input epsilon closure. And for Q4, so Q4 itself, it is having the Q4 input and transition of Q4 comma 0, and Q4 comma 0 there is nothing, pi, and the same thing for the input to 1 also, 1 input epsilon closure. Q4 transition of Q4 comma 1. So Q4 comma 1. So Q4 comma 1 also pi and the pi. So here no more new states are repeated, so that we will write the states here. So here I will name it as A. So A tends to, if you observe, A tends to, so here A is equal to Q1, Q2, and B is equal to Q3, and C is equal to Q4. And we will write the same thing in the diagrammatic representation. Initial state is A, and here the Q4 is the final state, so C is the final state here, B and C. So C is the final state. So A, which is having the input, so Q1, Q2 is there. So A, if you take A as an input symbol, for the A it is going to the 0 input symbol, for 0 comma 1 it is going to the same state, and from B input symbol we have only 1 input symbol to the C only, and for C we don't have anything. So this is what for C state, we don't have any we don't have any input symbol, so that this is the DFA, what we or converted the given NFA to. This is, if you observe, it is having the five states, and here if you combine together and after converting the given epsilon NFA to DFA, we got only three states. So that we just minimized, or we just converted the we just removed the epsilon moves from the transition, the NFA, and we need to convert it to a deterministic finite automaton. And this is about the conversion between the problems which are based on the conversion of epsilon NFA to DFA. So epsilon NFA is nothing but, first we need to remove the all epsilon symbols, or we need to remove the epsilon transitions for the given NFA, and then we need to find the new states for every state. Every new state we need to find the transitions, so that we can construct a new deterministic finite automata DFA. So these are all the examples we just discussed about the conversion of epsilon NFA to DFA, and these are the references. And these are the steps. So one more, let me explain one more time. So first, epsilon NFA to NFA. First step, what we have to do, we need to find the epsilon closure for every state, and then we just find the transitions for every epsilon closure of result what we got. So that result which leads to the value, and based on the resultant value we need to find the transition table, and then we need to convert it to a transition diagram. And this is about the epsilon NFA to NFA, and epsilon NFA to DFA. First step, what we have to do, we need to find the transitions of, we need to remove all the epsilon moves from the NFA, and then what we got the result, the new state is presented, so that we need to find the new state transitions, so that a new state transitions which are converted to a DFA. So this is about the epsilon. These are the examples, and these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.